Welcome back to BrewFix, where coffee meets craftsmanship. And today we're talking about something most people never consider when buying or using an espresso machine. Every espresso machine, no matter how expensive or beautifully engineered, is built around a compromise because engineering is never about perfection. It is about trade-offs between stability, cost, heat management, pressure control, size, energy efficiency, and user expectation. At its core, an espresso machine must heat water rapidly, maintain thermal stability under load, generate consistent pressure, and deliver repeatable flow. Yet achieving all of these simultaneously without compromise would require industrial-scale thermal mass, laboratory-grade control systems, and unlimited budget. Take boiler size, for example. A larger boiler offers superior thermal stability and recovery between shots because greater water mass resists temperature fluctuation, but it also increases warm-up time, energy consumption, footprint, and cost, meaning manufacturers must decide how much stability is enough for the target user. Similarly, dual boiler systems provide separation between brew and steam temperatures for greater control, but add complexity, components, and failure points compared to simpler single boiler or heat exchanger designs. Pressure control is another compromise, as traditional vibratory pumps are inexpensive and compact, but produce fluctuating pressure curves, while rotary pumps offer smoother delivery at higher cost and size. Even group head design reflects compromise. Saturated groups maximize thermal consistency, but require more metal mass and precise machining, whereas lighter designs heat faster but may drift under heavy use. Temperature control systems follow the same pattern, where basic thermostats cycle with wider variants, while PID controllers tighten stability, but add electronics that must be calibrated and protected from scale and voltage fluctuation. Scale itself becomes part of the compromise because machines must be designed to tolerate real-world water chemistry, meaning engineers balance material choice, internal channel width, and serviceability against manufacturing cost. Think of an espresso machine like a high-performance sports car designed for both city driving and racetrack performance. You cannot optimize fully for both without compromise, so engineers choose balance. Even the celebrated 9-bar pressure standard is a compromise between sufficient extraction force and manageable mechanical stress on seals and components. Pre-infusion systems represent another design negotiation, as extended low-pressure saturation can improve extraction uniformity but slows workflow and complicates internal plumbing. What makes this particularly interesting is that many users chase upgrades believing the next machine eliminates compromise, when in reality, it simply shifts where the compromise occurs. More stability might mean slower warm-up. More control might mean more maintenance. More power might mean more sensitivity to water quality. Understanding this changes how you evaluate equipment, because instead of asking which machine is perfect, you ask which compromise aligns with your workflow, water conditions, and volume demand. At BrewFix, we emphasize system thinking, and espresso machines are engineered ecosystems where every feature carries a trade-off. And mastery lies not in eliminating compromise, but in understanding it, compensating intelligently through maintenance, water management, and calibration, and recognizing that great espresso comes not from perfection, but from controlled balance within those design limits. Keeping your expectations realistic, your maintenance proactive, and your mornings caffeinated with engineered precision rather than marketing illusion.